Hello and welcome to Cuda Weekly. I'm your host Johan Bontes. Today I want to show you how you can basically use any standard library feature in Cuda as long as it's constexpr. You may remember this section of code from episode 2 where we have an assertion, Cuda assert, that we want to apply to all our Cuda functions. These return a status code, and we would like to examine the status code. If it's not success, then we would like to print an assertion with some information. In order to do that, we need to use a macro that uses the file and line sections here. Here we have a file define and a line define, and we paste those into the Cuda assert and parse that as a printf statement. Now this works, but it's not pretty. A cleaner way, and one that is standard compliant, is to use standard source location. I'll show you how this works with some code. When we look at the error message, it says source location is not found. Let's fix that. When we look at compiler support for C++, different versions, here we have C++ 20, you can see that NVIDIA nvcc is doing okay on the language features, but is missing on the library features. Now there is some project going on, libq++, that tries to fix that. But in fact, everything in this list that is constexpr has support for it. It's just that, well, it hasn't been publicized yet. Luckily, we have a fix. If you add experimental to source location, then it compiles. After you fixed a few more issues, let me walk you through the code. So here we have the header, experimental source location. We then have a function device exit. We'll get to that shortly. We have templated the function with an abort so that we can ignore the error if we want to see what happens afterwards. Sometimes that's useful to let the program run for a bit longer or to be able to pause it at this point so that we can see the status of our variables was before the program gets killed. Then we ask the file, the line, the column, and the function name from source location. Now, when you look at the call section, it says location is a source location, which we get from standard source location current. You have to call it in exactly this way, because then the line that you get, the current line, is from the call side and not from inside this function. We then print all this information in the print statement. If we'd like to abort, we call device exit, which does an assembly instruction exit on the device. There actually isn't an exit call, but you can make it like this. Otherwise, it just calls the standard C exit function. In our code, we generate a buggy function, which tries to put data into a null pointer, thereby generating our assertion, which we get printed here, illegal memory access in the function. Using the relaxed constexpr flag, you can put any constexpr function in your host code or device code as long as it can find it. For instance, the standard max function from the standard library. This function works as advertised, it outputs 2. This is useful because in the newest version of C++, there is a lot of support for constexpr function, and anything that has that in front of it you can use here in Cuda code. You can also specify your own constexpr functions. They don't need device host prefixes. You can just code them up exactly like you would in normal C++ code. As you can see, this works as expected. The code gets called from the device, this global function, without any specifiers in front of it, as long as you have the relaxed constexpr specifier in your compilation statement. Okay, I would like to leave it here. I hope this motivates you to use constexpr whenever you can. If you enjoyed the episode, feel free to give it a thumbs up, and I'll see you next week.